Today's lesson 10.3 is on the area of a regular polygon. We're going to start with a quick review of an area of a triangle, and then we're going to talk about, well, what makes a polygon regular, and the fact that regular polygons are all around us. Then we're going to break down a regular polygon into its component triangles, and then we'll realize that the polygon area must be the sum of the area of those triangles, and since we know the area of a triangle, we can solve for that. And then we'll come up with a formula based on those triangles, and then finally we'll do a bunch of example problems. Alright, so by the end of the day you'll be able to solve three kinds of problems to find the area of a regular polygon. You'll be able to find the rounded value, the exact value, and if not all the values are given for you, you'll be able to use special triangles to find the necessary values that will then allow you to solve to get the area of the regular triangle. Alright, so let's do a quick review. The formula for the area of a triangle is 1/2 the base times the height. So right there's my base, it's a right angle, so there's my height, there's my base, perpendicular to my base is my height. 1/2 base times height is the area of a triangle. And if you forget, you can always calculate it by using a formula for the area of a parallelogram. So the area of a parallelogram, or a rectangle, as I hope you know, is base times height. So if I take that and divide it into two equal triangles, now I have 1, 2, and so if there are two of them and the whole thing equals base times height and there are two of them, then each of the triangles must equal 1/2 that, or 1/2 the base times the height. Just a way to remember the formula for the area of a triangle. Okay. A regular polygon. A polygon is regular if two things are the case. First, there are polygons that have each side is congruent. So each of these sides is congruent to each other. And secondly, each of the angles is congruent. So all of these various angles are congruent to each other. And here are some examples of congruent polygons. Equilateral triangle and square have special names. After that, it's just called regular whatever, regular polygon, regular hexagon, and so forth. Okay. And regular polygons are everywhere around us. If you ever looked at a soccer ball is those blue panels are all regular polygons. Those are all pentagons, and the white panels are also pentagons, just a little bit larger size. They sew together to make a soccer ball. A stop sign is a 8-sided regular polygon called an octagon. The place where the Defense Department is in what's called the Pentagon, and that is a very large building that is in the shape of a regular pentagon. And then finally, if you've ever seen a honeycomb, bees make honeycombs, and those are regular hexagons. So again, these regular polygons are all around us. Right, so let's do a quick little in our notes about regular polygons. So regular polygons are polygons with all sides congruent and all angles are congruent. Okay, so I've drawn a regular polygon inside a circle, inscribed in a circle here. You can see the C is the center of both my center of my polygon and my circle. And the distance from the center to the vertex of the polygon is what's known as the radius. And you'll see that the radius is the same for the circle and the polygon that's inscribed in that circle. So AC and CD are both radiuses of this circle here. Alright, now regular polygons can be broken down into congruent triangles. And if a polygon has n sides, it can be broken down into that number of triangles. So here is a hexagon. It has 1, 2, 3, 4, 5, 6 sides. And I can break that down into 1, 2, 3, 4, 5, 6 congruent triangles. Here is an octagon. Octagons have 1, 2, 3, 4, 5, 6, 7, 8 sides. And I can break this octagon down into 1, 2, 3, 4, 5, 6, 7, 8 8 congruent triangles. Each of those triangles is congruent. They're all the same thing. Okay, so to find the area of a regular polygon, we just need to find the area of the triangles. So here is a polygon, and this is a hexagon, and this hexagon has 6 sides. And therefore, it has 6 triangles. It looks like that. If I tell you that each side of this triangle, of this hexagon is 2 centimeters, so we'll just look at just this red triangle for right now. That's 2 centimeters. And I tell you that each of the heights of those triangles is square root of 3 centimeters, so we can draw that in. That line right there is called the apothem. The apothem is the distance from the center to the midpoint of one of the sides, or the height of one of the triangles. Okay? Now we can realize that each of these triangles has an area of 1/2 base times height, so that would be 1/2 of my base times my height, so that would be 1/2 of 2 times root 3. Multiply that out, and I get that that is simply root 3. So this red triangle here has a area of root 3 centimeters. Well, there's 6 of them. And if there's 6 of them and each one of them has an area of root 3, then all 6 together must have an area of 6 root 3 square centimeters. Alright, so now we can put in our notes the definition of apothem. Apothem is the perpendicular distance from the center to the midpoint of any side. There's the example right there, CB is the apothem. In a regular polygon, all apothems are equal. And the apothem is the perpendicular bisector of a side. Those are all true about apothems. All right, now let's use what we've learned about the apothems and triangles to come up with a formula for regular polygons. Here is a regular polygon. It's got, okay, so to qualify it, I have to first of all figure out how many triangles it has, and then I'm going to figure out the area of that triangle. Okay, and the area of that triangle is 1/2 base times height. And I'm going to then multiply the 1/2 the base times the height, that's the formula for that red triangle. Then I'm going to multiply it by the number of triangles, and that will get me the area of the regular polygon. Now let's start substituting some stuff in. Okay, that the base of each of these polygons is the side of a polygon. So right there is a base, and I'm going to call it a side. So instead of saying base up in my formula, I'm going to change base into side. Okay? Also note that the height of each polygon right there is an apothem. So I'm going to change in my equation up at the top, I'm going to change height to apothem. Also note that the number of triangles equals the number of sides of the polygon. So if I've got 8 triangles, I also have 8 sides. So here I'm going to just change number of triangles to number of sides. And finally, note that the perimeter of a polygon is equal to the side of a polygon times the number of sides. So here's the number of sides, and so there's side and the number of sides. If I get rid of those, I can instead call side times the number of sides the perimeter. And now I have a formula that the area of a regular polygon equals 1/2 perimeter times the apothem, or 1/2 PA. So now I can use that in my notes to write my formula. The area of a regular polygon is 1/2 perimeter apothem, or we write that down as 1/2 PA. And the area of all congruent figures, if two figures are congruent, then their areas are equal. Right? That makes sense. If they are congruent, then they must have the same area. Alright, so I've made for you a graphic organizer. You can find it within Canvas. The idea is just to help you figure out both the perimeter and the apothem, and multiply it together, and then multiply by 1/2. So here's an example problem that is in your notes that you should do. So try this problem, pause, try this problem on your own, and then come back and see if you got the right solution. Okay. This problem says that it's a pentagon. Pentagons have 5 sides, and the side length of each side is 10. So I multiply the number of sides and the side length together, I get the perimeter of 50. If I then take 50 and multiply it times my apothem, which in this case is 6.9, 50 times 6.9 is 345. But the formula is not apothem times perimeter, it's 1/2 apothem times perimeter. So if I take 1/2 of 345, multiply it out, I get that that's 172.5. So the area of a regular polygon with an apothem of 6.9 and a side of 10, rounded to the nearest tenth, is 172.5. Let's try another problem. This time it actually just gives us a diagram rather than just the information. So once again, I have to count up the number of sides, and when I count them up, this is an octagon with 8 sides, Each of those sides is 8.4, so I multiply that together to get 67.2 as my perimeter. My apothem, which I can see in the diagram there, is from my center to the midpoint of one of the sides, is 10.2. If I multiply 67.2 times 10.2, I get that's 685.44. Cut that in half, and that becomes 342.7 rounded to the nearest tenth. Alright, if you feel comfortable having done those problems and you think that you can solve area of a regular polygon rounded, then please go to classwork 10.3.1 and do that classwork and then come on back. Alright, previously we did problems that were rounded. Now let's do some problems that are exact. So here's my graphic organizer again. This is a triangle, so it's got three sides. Each side length is 10 root 3. If I multiply that together, that becomes 30 root 3. My apothem is 5. Multiply that together, and that becomes 150 root 3. Take 1/2 of that, and that's 75 root 3. And since I'm going to find the exact area, that's what I have to leave it as, 75 root 3. If I put it into a calculator, it would round it, and I'm not asking for a rounded value. I want the exact value, which in this case is 75 root 3. Let's do example problem 4 to find the exact value of this one. Once again, here's my graphic organizer. I've got 6 sides. Each side length is 10, so the perimeter must be 6 times 10 is 60. Multiply that times my apothem, which is 5 root 3, and that equals 300 root 3. Take 1/2 of that, and it's 150 root 3. Okay, so we've now done a couple problems where we find the exact value of a regular polygon. If you feel comfortable having found those exact values and think you can do those problems on your own, please go to classwork 10.3.2 and try the area of a regular polygon exact, and then once you've solved those, come on back to do our final problems. Sometimes we'll be given a problem like this where I don't have enough information. I have the apothem is 11, but I do not have is how big a side length is. But luckily, I can draw this line here, and when I do, that turns this into a 30, 60, 90 triangle. As a result of that, now I can try to find what I need. So what I do, I'm going to first identify this as a 30, 60, 90. This is, so I'm going to put my values on of n root 3, and 2n. Now I need to find a side with a value and use the equation. So I have n root 3 equals 11, so I can use that to solve the other sides. N root 3 equals 11, divide by root 3 on both sides. I end up with n equals 11 root 3, oh, I'm sorry, 11 over root 3. I can't have a root on the denominator, so multiply by root 3 over root 3, and I get 11 root 3 as a numerator and root 3 times root 3, and the reason I multiplied by that is because root 3 times root 3 is of course 3. So now I have that n equals 11 root 3, and looking up at my diagram, I have that part of the triangle is n, and this other part right here is n. So what I actually want is the side of the polygon is 2n. So that would be 22 root 3 over 3. And the apothem is 11. So now that I know the number of sides, the side of the apothem, the side of the polygon and the apothem, I can solve it. I've got 6 sides. Each side length is 22 root 3 over 3. Multiply that out, and that's going to be 44 root 3. Times my apothem, which is 11, multiply that out, and that's 484 root 3. Cut that in half, and that's 242 root 3. Okay. Here's another example. This time we have a side, but not the apothem. Once again, I can draw my 30, 60, 90 triangle. I can write my ratios on n root 3, 2n. Find the side. I know that n equals 6 root 3, and use that to calculate my side, because again, that's n, so I know 2n equals 6 root 3 because the entire side is 6 root 3, so n equals half of that, or 3 root 3. So the apothem is n root 3, which is going to be equal to 3 root 3, which is my n, times root 3. Root 3 times root 3 is 3. 3 times 3 is 9. So now I have the apothema is 9 and the side is 6 root 3. So I can multiply it, do this out. I've got 6 sides. Each side is 6 root 3, so the perimeter is 36 root 3. My apothema is 9. Multiply that together, I've got 324 root 3. Cut that in half, and that's 162 root 3. One more example. In this one, I am given the radius, but not the side or the apothema. I need to solve both. So once again, this is a 30, 60, 90 triangle. I'm going to identify the sides as n root 3, 2n. I'm going to find which side has a value. In this case, 2n equals 12. So I'm going to solve that and find out that n equals 6. If n equals 6, then the apothema is n root 3, which is just 6 root 3. And a side, again, is I've got that n and then another n. If 1n is 12, then 2n, I'm sorry, if 1n is 6, then 2n is 12. So the side of the polygon is 12. So now I have the information I need. I know that the number of sides I have is 6. The side of each of those sides, the length of each of the sides is 12. So when I multiply together, I've got a perimeter of 72. Multiply that times my apothema, which is 6 root 3, and I end up with 432 root 3. Cut that in half, and I end up with 216 root 3. That's the exact answer. Okay, so if you feel comfortable doing using using special right triangles to find the area of regular polygons, you can go off and do classwork 10.3.3.